Hello everyone, my name is Jin Zhang, and today I'll be presenting my project on database system for a nonprofit organization. This project focuses on designing a database system using MySQL database. Also, uh, I'll be implementing indexing and denormalization to improve performance. Let's get started. I choose MySQL on Azure Flexible Server as my database platform. Azure provides free student account, making it a great choice for our database solution. I create a database here called NonprofitDB and use MySQL Workbench to execute my MySQL commands. To properly structure the data, I create an enhanced entity relationship diagram here. The person entity is the super type with the three subtypes: employee, volunteer, and donor. Additionally, the donation table here connects the donor to the item entity, allowing user to track donation over time. The database schema here defines table, relationship, and constraints. Each table has primary keys, and relevant tables uses foreign key with on-delete cascade to maintain the data integrity. Here are my 5 complex SQL queries. On the left side are the questions, and the right side are the corresponding SQL commands. The first one is getting a list of all donors with their donations. And this query retrieves a list of all donors and the total number of donations they have made. We use select a statement to specifically tell we want to return donor's social security number and donor's name, and we use income to calculate the number of donations. And we use using SSN to match each columns, and meaning each donor is matched with their corresponding details. This query joins 3 tables to get donor detail and their donation histories. And second one, get a list of employees who are also volunteers. And this query retrieve a result by joining person, employee, and volunteer tables. It filter out people who are not employee first by joining employee table. Then it further filter out people who are not volunteers by joining volunteer table. And third one is list all people who are not employees, volunteer, or donors. Similar to the second one, this time we just filter out the people who are not in the employee table, volunteer table, or donor tables. And the fourth one is get a total value of donation per donor. And the last one is list employees, volunteer, and donor in one table. I ran the query on MySQL Workbench, and here is the result I got before I implemented any optimization. I measured query execution time using Explain Analyze to measure execution time. Some queries were taking longer due to full table scan and complex joins. Okay, now to improve query performance, I apply index on key columns to speed up lookup and joins. The following index were created. By indexing the database, now we can quickly locate records without scanning entire table. This will reduce execution time for certain queries. Here are the results after indexing. Because our table are extremely small, we have less than 100 rows of sample data in each table, so it's hard to see the performance improvement here. But imagine if you have a large database with a million rows of data. Doing index will increase your search speed by 10 times or even 100 times faster, depends on your data structure. The normalization is another way that you might be able to do for better performance. For example, we could add another column called the total donation value in donor table. That way, when we try to get the total donation value of a donor, we don't need to join multiple tables for result, and that will result in better performance. In conclusion, database optimization is essential for improving query performance, reducing execution time, and effectively handle large data sets. But there is always trade-offs. Optimization should be tailored based on query patterns, data set size, and system requirements. Thank you.